Okay, everybody, this lesson is on the properties of logarithms. We're going to list out each property here and do an example of how each one is used. The first one right here basically says this. If I put it into, if I take the log base a of 1, that logarithm is asking us the base a to what power, to what exponent gives us 1. No matter what the base is, a to the 0 power gives us 1, so this one is equal to 0, as we have written here. Okay, so that's our property number 1 there. The log base a of a. This is asking us a raised to what exponent will give us a. And that exponent is always going to be a 1. And so the log base a of a is always equal to 1. That's property number 2. Log base a of a to the x. Now what this logarithm is saying is that a raised to what exponent is equal to a to the x. Well, to make both sides of this equation equal, this exponent right here must be x. A to the x equals a to the x. And so this logarithm is just x. That is property number 3. And it's very simple to see if you just put this in exponent form like we did in the last lesson. The base a to the x is equal to a to the x. Same thing up here for property 2. A to the first power is equal to a. And for also property number 1, a raised to the 0 power is equal to 1. Now property number 4, we don't use too often, but here's where it comes from. The definition I gave you for logarithms in a previous lesson was y equals the log base a of x means that a raised to the y power equals x. That's the definition of logarithm. Now if that's the case, if y equals this, then I can replace this y with log base a of x. And if I do that, I get a, this a right here, a to the log base a of x is equal to x. And that's the property number 4 that we have right here. An example of its use would be, supposing we had 5 to the log base 5 of 3. According to this property, that would just equal 3. Another example of that would be 10 to the log of x. Since I didn't put a base there, that's a common log. Its base is 10, right in there. Common logs have base 10, and that would just equal x. A couple examples of that property number 4. Okay, now we're at, let's see, this is property 1, 2, 3, 4, and property number 5 now. Property number 5 basically says that we can take multiplication, we have multiplication in our x times y, and we can turn it into addition. Here are some examples of using this property. If I have the log of 5 plus the log of 2, according to this property, I can write that as 1 logarithm 5 times 2. The addition becomes multiplication. This is the common log of 10 And remember the base here is a 10, so 10 to what power gives me 10? That answer is a 1. That's a 1. That's an example. Here's another example of that. If I have the log of 4x, then I can use this property to split that up into two logarithms. That will be the log of 4 plus the log of x. Here's another one. If I have the log of 3y, then that will be the log of 3 plus the log of y. And one more here. If I have the log of a plus b, a common mistake is to think that that's the log of a plus the log of b, but that's not how the rule works. This cannot be simplified. But if I have this, the log of AB, that would be log A plus log B. Okay, that's how property 5 works. We're at property 1, 2, 3, 4, 5. Now property number 6 here. Property number 6 basically says that division of a logarithm, division within a logarithm, can be turned into subtraction. For example, if I have the log of x over 5, that can be written as the log of x minus the log of 5. Likewise, if I have the log of 1 over y, according to this property, that would be the log of 1 minus the log of y. Log base 3 of 36 minus log base 3 of 4. Okay, now going into the reverse direction here, I can write this as one single logarithm. This would be the log base 3 of 36 divided by 4. That's the log base 3 of 9. And I know what that is. 3 to what power gives me 9? That's a 2. There's a 2. Okay, so there's how property number 6 works. Property number 7 down here says that if you have an exponent within the logarithm, you can move it out in front. And there it is right there. Here's a couple examples of that. If, for instance, I have the log base 2 of x cubed, this property says that I can take the 3 in here and move it to the front. And so this is equivalent to log base 2, or, oh, forgot the 3. This is equal to 3 times log base 2 of x. Here's another example of that. Suppose I have the natural log of 2 to the 5th power. I can take this 5 and move it to the front, and that is equal to 5 times the natural log of 2. And so that's how our properties work. Okay. Write as a sum or difference of logs. In other words, we're going to expand out these logarithms. Here's our first example. we're going to take the log of 5x squared, and we're going to expand it out. We're going to write it as a sum or difference of logarithms. Now, the first thing I'm going to do is I'm going to use my property number 5, property 5, which says that that multiplication in there can be turned into addition. So this is now the log of 5 plus the log of x squared. Now I can use property number 7. And property 7 says that I can take this exponent, which is inside the logarithm, and move it to the front. So this is the log of 5 plus 2 log x. And I've written it as a sum of logarithms. Here's another example of that. The log base 7 of square root m over n. Now, first of all, a square root is really a 1/2 power, so this is really m over n all raised to the 1/2. Now, since the entire, actually, what I'll do is I'll distribute the 1/2 here. That's probably better. So this is equal to the log base 7 of m to the 1/2 over n to the 1/2. Okay. Now, I haven't used any of my properties yet, but now I am. I'm going to use property number 6. And property 6 says that I can turn the division in here into subtraction. So this is now the log of m to the 1/2 minus the log of n to the 1/2. Next, I can use property 7. And property 7 is the one that allows us to take this exponent and move it in front, as well as this one right here, which will give us our result 1/2 log m minus 1/2 log n. And we have it written as a sum or difference of logarithms. Here's a couple more of those. Log base 5 of a squared b cubed over c. Okay, I'm going to write out as a sum or difference of logarithms. First thing I notice here is the division. The division can be turned into subtraction. This is now the log of a squared b cubed minus the log of c. That's using property number 6. I can also use property 5 right here. Property 5 says that I can split that up into addition. This is the log of a squared plus the log of b cubed, and then minus the log of c. That's property 5. And now finally I'm going to use property number 7. And property 7 is the one that allows us to take these exponents and move them to the front. And I have 2 log a plus 3, that's a 3 in there, 3 log b minus the log of c. And there is my result right there. Okay. Also, we can go in the reverse direction. Write as a single log. For example, 4 log m plus 3 log n. That's expanded out, but I can write this as a single log by using my properties. The first one I would use is property 7. I'm going to take these numbers and move them back in as exponents. That becomes the log of m to the 4th plus the log of n cubed. Then I can use property number 5 to turn this addition into multiplication. I now have the log of m to the 4th times n cubed, and I've written it as a single logarithm. Here's another one. Log of x plus 1 plus log x minus 2/3 log y. Oh, there's a 3 in there too. There's a 3 right there. Okay. We're going to write this as a single logarithm. The first thing I'm going to do is use my property number 7, and I'm going to put the 3 here back in as an exponent, and also the 2/3 as an exponent. So this gives me the log of x plus 1 minus the log of x cubed. Oh, that's a plus sign, sorry. It's a plus sign right there. And then minus the log of y to the 2/3. Now the addition right here means that those two logs can be combined into one single logarithm. That's now the log of x cubed times x plus 1 minus the log of y to the 2/3. So that's using property number 5. Property number 6 says that this subtraction here can be turned into division. I can now write this as one single logarithm. This is x cubed, x plus 1, all over y to the 2/3 power. And there we have written it all as a single logarithm. Okay, just one more here. Just one more. Write as a single log. Natural log, or 5 natural log 2 minus 2 natural log 3. Natural logs work just like regular logs. Their base is just e, that's all. So just like in the last examples, I'm going to take these numbers and I'm going to put them in as exponents. So that's property number 7 that I'm using. This is the natural log of 2 to the 5th minus the natural log of 3 squared. And that's, let me write that as, that's 32 there, and that's 9. Next, I'm going to use property number 6. And property 6 is the one that says that the subtraction can be turned into division. This is now 1 natural log of 32 over 9. And there it is. Some students make the mistake of writing it natural log 32 over natural log 9, and that is incorrect. Not the same as this. This is correct. Correct. Okay, that's our lesson on our properties of logarithms. You gotta be kidding me.